Okay. It says at the very top, it says inductive reasoning. Have your name on it. Okay. We are doing that one. We're going to start where it says segment, proofs, references. We're going to start where it says segment, proofs, references. It looks like this on the first page.
Don't talk and then they won't have to do that. It's real simple. I thought we were done with the whole.
Okay. So these last two sections are we're still doing more proofs, okay? In 2.6, we learned algebraic proofs, proofs over algebra problems, okay? And the reason we did that was because we should be more familiar with algebra, so there's an easier way to learn the proof process. Now we're going to transition and we're going to start doing geometric proofs, the proofs over geometry, because we're in geometry, okay? So we're going to apply that proof process we learned in 2.6 with algebra, and we're going to apply it to geometry, okay? Now, I'm going to ask for patience today, okay? Remember I asked for patience a few classes ago as well with one of our lessons when it was really confusing. I'm going to ask for patience today as well, okay? Marissa, please put that away, okay? Last warning, okay? So I'm going to ask for patience today with this as well because we're going to go through proofs. It's going to be really confusing. You're going to be really lost, and it's going to take time, okay? It's going to take time. So just please mentally work on accepting that it's going to take time to understand, okay? Please don't interrupt me, okay? We should take time. I appreciate it. Okay? We should take time to just, that's going to take time to understand this process. It's a new way of thinking, and it's really, really confusing at first. I know it might be frustrating, but I'm going to ask for deep breaths and an understanding that I'm not asking you to get it perfectly right away. Not at all. I'm asking you to work with me on it and give it time. Okay? That's what I'm asking.
So we're not going to have a quiz on this anytime soon.
Okay? We're not going to having a quiz on it today. No, we'll have some homework to help us review and practice. We're going to start that in class. Okay? Okay. Thank you. All right. So we have this sheet that says segment proofs reference. We're going to use this sheet as a helpful tool as we go along. Okay? So we can refer back to this page of notes specifically as we go along. Okay? It's a nice organized place for some of our properties we're going to talk about. So we have these properties of equality we talked about the other day. 2 classes ago we talked about these properties of equality that we used. And these were a lot of the things we used in our proofs last time on that quiz as well. Now these properties can use with equal signs, and they're equality properties. They can use with equal signs. Now the following properties, they're properties of congruence. So we can use them with statements that have congruent symbols. Okay? So equality, equal signs, congruence symbols. Okay? So we've seen the reflexive property, symmetric property, and transitive property before. We saw them with the equal signs. We're saying, hey, those are also true with congruence, and here's how we're going to use them. So reflexive property of equality was like 8 is equal to 8, just saying something's equal to itself. So for reflexive property of congruence, for any segment AB, so if there's any segment out there, segment AB is going to be congruent to itself, segment AB. So it's the same idea as the reflexive property of equality, that a number is equal to itself, as saying congruence, a segment is congruent to itself. It has the same length as itself. It's like Mr. Castle is the same height as Mr. Castle. Well, okay, yeah, okay. Or Wyatt Renner is the same height as Wyatt Renner, okay. Or Marissa has the same shoe size as Marissa. Well, yeah, okay, that makes sense, okay. Then we have our symmetric property of congruence, okay. If we refer back to our symmetric property here, that was like where A equals B, then we're going to have B equals A. We just flipped it around, okay. So symmetric property of congruence. So segment AB is congruent to segment CD, excuse me. Then we can flip it around. Segment CD would be congruent to what segment?
AB.
AB. Thank you, Marissa. Go ahead. Whoever's sharp, that's go ahead. I appreciate you holding off for a second. So our transitive property, we also had that earlier. That was our transitive property for equality. Was like if A is equal to B and B is equal to C, then we could go from A to being equal to what? C, right? We could go first to the last. If they're both equal to B, they're equal to each other. Okay? So we have our transitive property of congruence too. Same kind of thing. if segment AB is congruent to segment CD, segment CD is congruent to a third segment, EF, can somebody tell me what we can conclude from that?
AB equals E.
Segment AB is congruent to segment EF, yeah. Excuse me.
We're gonna have like a lot more variables in this now.
These aren't necessarily variables. Remember, these are points. So segment EF is like you have this line segment with endpoints E and F. Do you remember that? Okay. So it's not necessarily variables. We're gonna have a lot more letters. Because
Okay,
we're
so
doing
what is
things in a lot
different
of
about this than last time?
So now we're doing those proofs, and instead of doing over algebra equations, solving those, we're gonna prove that two different things are congruent, or that something's the midpoint. We're just gonna prove different things about with geometry. So today we're doing a lot of stuff with segments, line segments, okay? In the future we'll be doing a lot of stuff with angles, okay? So going on right below this, okay, we have a couple definitions we're gonna talk about. Definition, that's like if you look up a word in the dictionary and it says, oh, well, like this means this, okay? So like wet means that it's like it's covered in water, right? You know, that kind of thing, okay? So, so definition of congruence, well, for it to be congruent, it just means that segments are congruent if and only if they have the same measure. So we're saying, hey, if two segments have the same measure, they're congruent. If they're congruent, they have the same measure. We learned that back in chapter 1 to be true. So, if segment AB is congruent to segment CD, then that means the measure of segment AB is equal to the measure of segment CD. We're saying, hey, if the two segments are congruent, they have equal measure. Okay, that's just using our definition. That's what congruent means. That's what it means to be congruent. Just like if you say, you know, like, oh, like someone spills water on the floor. Oh, the water is wet. Someone's like, well, it's not wet. We can say, literally, the definition, it's wet. Like, you can't really argue that if you say it's a definition and it's exactly what it is. This is just a definition. That's just exactly what congruent means. Okay, and we can also go the other way with it. That if you have the measure of two segments are equal, then we can say those two segments are congruent. So we can go the exact reverse way with it too. Yes, Ian.
Can I sit behind Cal so I can see the board?
Yes, you may. Thanks for asking. What was that other something? Okay. So we're saying we can go both ways with that definition there. And we also have definition of midpoint. If you recall, midpoint was where you had like a line segment here, but B is exactly in the middle. Okay? So the midpoint of a segment divides the segment into two equal or congruent parts. So if M is the midpoint of segment AB, so if M is the midpoint of segment AB here, so if I even draw this out here just to show you guys an additional picture, segment AB, now you know M is the midpoint, so I label that. Then we can say that the measure of segment AM is equal to the measure of what segment? MB. So if M is the midpoint of this segment AB, well A and M has to be the same as M to B.
Oh my gosh.
Oh, sorry. Yeah. I know, it's annoying. I hate it. Okay. So it's like saying if Plattsmouth is halfway between Omaha and Nebraska City, okay, which is kind of close to this, okay? Not exactly, but it's close to, okay? So if Plattsmouth is halfway between, or the midpoint of Omaha and Nebraska City, okay, then Omaha to Plattsmouth is the same distance as Plattsmouth to Nebraska City. Saying the same exact thing, okay? So, postulate, we have the segment addition postulate. I like to joke and say it's like post-Q-late, kind of like Post Malone, but post-Q-late, okay? But you might not like that, okay? You might just think that you're better now, okay? So if A, B, and C are collinear, A, B, and C are collinear, meaning they're on the same line. I just referenced the Post Malone song. If A, B, and C are collinear, meaning they're on the same line, they're collinear points, and B is anywhere between the 2 points, anywhere between, then we say the measure of AB plus the measure of segment BC is equal to the measure of what segment? We take AB, add up that measure, plus the measure of BC, what do we get? AC, the whole thing. That was our part plus part equals whole from chapter 1.
AC air conditioning.
Yes. Okay. That'd be like it's saying, hey, for me the whiteboard is like 3 tiles of carpet, okay? And then the whiteboard to the cabinet is like another 8 tiles of carpet, the whiteboard to the cabinet is another like 8 tiles, just a guess, okay? Then me, the cabinet, we add those 2 together and we get how far it is, okay? Or it's like from me to Gracie is like 3 tiles, and Gracie to Wyatt is like 6, and me to Wyatt would be the adding, so 9, okay? Yes, and yes. You have like a really bad pencil. Okay, let's go ahead and flip the page. Okay, we're gonna practice some of these. Okay, we're gonna go over them like we did, kind of like with our algebraic ones. Okay, we went over a few. What I'm gonna have you guys do is I'm gonna do the first couple up here as a class, and then I'm gonna have you guys I'm gonna partner you guys up to do the rest. Okay, and then we'll talk about them up here.
Wait, like we get a bigger partner?
Okay, so we have 12. No, I'll partner you up. Okay, we have 12 here. It's just a real quick thing. Okay. So we have 12 here, but I split it up where we have 5 with our property bank, and then we have 7 with our property bank on the next slide. So I still have 12. They're just mixed between the 2 slides. Okay, so I can fit them all up there well. Okay. So number 1, if PQ is equal to PQ, if the measure of PQ is equal to the measure of PQ, then it's congruent to itself. So what tells us that if the measures are equal, then it's congruent? Marissa? Not quite. Reflexive property, we're just saying that just if we like covered this up, that'd be the reflexive property. But here, how do we go from them being equal to them being congruent? If we look back to the previous page, where do we see an example of that? Clyde? Definition of? It's the definition of something, of what? Congruence. So I'm okay with the shortening definition to DEF. We're still going to read it if we say out loud, definition. Okay? Just like if you see the abbreviation for street, it's ST. You're not going to say something is like Washington's. No, you say Washington Street. That'd be weird. Like Ian's laughing because that's weird. Okay, right? Wouldn't it be weird? Someone's like, yeah, I'm gonna go down Washington later, and then I'm gonna go over to I don't know, like Monroe Drive. Okay, something like that. I think that's weird if people do that. Okay, you say street. You say drive. So we're gonna do the same thing. You don't say def. We say definition of congruence. Okay, but it's gonna allow us to abbreviate it as we write it. Okay. We're going to do number 2 together as well. If K is between J and L, so if K is somewhere between J and L, then JK plus KL is equal to JL. Marissa?
Segment addition postulate.
Nailed it. Segment addition postulate, saying, hey, if you had these 2 parts, you get the whole thing. And I'm okay with us writing it as seg add post, but we still read it as segment addition postulate. So read it as segment addition postulate. Okay.
That does not look like postulate. Oh wait, yeah it does.
Okay, I thought so. Okay. You guys are gonna do number 3, number 4. Okay. You 3 are gonna do number 5. Okay. You 2 are gonna do number 6, number 7. Okay. Taylor and Braden number 8. Okay. Celeste and Marissa number 9. Okay. Colin and Peyton number 10, and Nolan and Sam number 11. Okay. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Yes.
You did not pick a good number for us because we were both not here for the days that we did those.
Ooh, have you watched the video yet? Oh, you're supposed to, right?
There's a
Well,
video?
you told me to watch it. I was
Yeah.
busy though. I had
We
lots
should
of
watch it in
Yeah.
class.
Yeah, it's symmetry. What?
So, this plus this equals this. These two are equal, right? But change from here to here. Actually, let me figure out something. So let's see what this is, okay?
It's gonna smack it. Like in the movies where they make
From this equation. The equation right below it. Yeah, RS and now WX, right? This is equal to WX. What it tells us that if these two are equal, we can just switch them out.
Or distribute.
The truth is like we're
What do we choose?
if you sub
I was gonna get
something
some like that,
in,
but
you're putting it in place of it. So we were saying, hey, if they're
the
equal,
I was gonna get me
substitute it in.
like that.
It's kind of like in a recipe.
Like with the
Okay, they're
tea.
those are baked. Okay, you can substitute in butter for margarine or margarine for butter. Okay, because butter tastes better.
So I just got white, so now I'm baking.
Use it. Does that make sense? It's kind of the same idea.
I tried not to, but God just wanted me to make it. What? I want to get the ones where like it has the blood on them. You've never seen them? They're super cool. They're black and white, and then like they have like drips.
Oh. Yeah.
Or I want blue ones.
We're actually gonna go ahead and talk about this one up here, okay? So number 3, ladies, what did you have?
Ew, no.
Okay, I'm actually gonna disagree. If it was like going from this to make equal, I would agree. Okay, what do you say? It is reflexive. So saying something's congruent to itself or equal to itself is our reflexive property. Okay, so everybody should be filling in number 3 with us now. For this, bless you, bless rain,
Bless
bless you, bless rain,
bless
don't have
you.
to forget. Okay, if something's congruent to itself or equal to itself, it's our reflexive property. Okay. Okay. Well, good thing I allow you just to abbreviate it. Right. Isn't that awesome, Colton?
Yeah.
Yeah, I thought so, okay. Number 4, okay, Kale and Ian, what did you guys have? The addition property. You might be confused and think, oh, is this segment addition postulate? But it's saying it's addition property. Here's why. We go from RS is equal to TU, and what changed? Well, we added the same XY to both sides. The addition property, thank you, Ian, okay, tells us that we can add the same thing to both sides, and it's perfectly okay. Just kind of like earlier we added like 8 to both sides, or we add 7 to both sides, okay? Number 5, okay, Skylar, Grace, and Casey, what did you guys have?
Symmetric property of congruence.
I agree, it is our symmetric property, very good, okay? It is our symmetric property. We just went here and we flipped it around, that's all we did. AB is equal to D, well, D is equal to AB, we flipped it, okay? If I'm the same height as Casey, Casey's the same height as me. We flipped it around, okay? Not necessarily true, but I'm just saying that's what we did. We flipped it around, okay? Going on to number 6 here. Okay? What did you guys have, Mason and McKenzie? I would agree that is the definition of midpoint, okay? Now we can just abbreviating it this way. Once again, we're not gonna say def of mid. We're gonna say definition of midpoint, right? That'd be weird, like saying like Washington, okay? Okay. Same thing, definition of midpoint.
It doesn't sound weird when you say definition.
But I want you guys to think about this.
I know, but I'm just saying.
Yeah, I know. I get it.
Our abbreviations that you just say like
Yeah, sometimes that's true. Yeah,
Miss,
But we're
we
gonna-
say miss and it's MRS.
not Mrs. Miss is MISS.
Or yeah. And like Mr. It's not like
You don't say
M
murder.
or
Mr. is the abbreviation of
Or
this.
hostile.
or
It's because when they
It is
get
abbreviated
married,
this
they're
way.
two
You don't say
names
Murph,
combined and it
You say
becomes
Mr.
Okay, when you say miss, you do MS.
Yeah.
That's miss.
That's
MS
Miss.
is a bad
You do
word.
MS.
is
MS
Ms.
for teachers.
Ms.
What's MS?
Ms.
MS is for people who
MS
aren't
is like a
married.
thing that people get. I don't even know.
MRS.
Is it MS like
when you're married. Yeah,
It's also
MRS is when you're married.
that's
So
it.
you
It's
do.
also I'm not gonna talk about it. Okay. Anyway, sidetrack. Let's get back on track. Number 7, Clyde and Wyatt. What do you guys have?
Dude.
What? I agree. Transitive property. 7 is a transitive property.
Transport.
Segment FG is congruent to segment HI. Segment HI is congruent to segment JK. So they're both congruent to segment HI, so they're congruent to each other. Okay? They're both congruent to segment HI, so they're congruent to each other. It's kind of like you can cross out the middleman, like our law of syllogism. They're congruent to each other. Okay? Number 8, Taylor and Braden. What did you guys get for this one?
Well, honestly, didn't do it.
Okay, cool. Braden, what did you get?
I got the transitive property of congruent.
Not quite. No, not number 8 here. Okay. That'd be true for number 7. On number 8, okay.
I was changing.
No, it's not right.
I wasn't laughing at him. I was laughing at Gracie.
So, if AB plus CD is equal to EF plus CD, what changed from this equation to the second equation?
The
EF is still EF.
I take it back. There's no AB.
AB is AB.
I don't care.
What else? What did we change? What don't we have?
What equals each other?
We don't have CD anymore. What did we do with CD to get rid of it from here?
Subtracted
You
it.
sort of subtracted it. What do you do from here? Subtracted it. What tells us that we can subtract from both sides?
Sub.
The subtraction property.
Damn.
You sound like Mr. Weenie
Off of what?
Like,
Mr. Weenie the little dog.
Number 9, ladies, what did you get?
Substitution.
I agree, that is substitution property. Let's look at number 9 here, please, and thank you, okay? If PQ plus RS is equal to TV, and RS is equal to WX, then PQ plus WX is equal to TV. If we look what happens here with these equations, PQ is still PQ. RS is WX now, and TV is still TV. So what changed? RS became WX. We're able to do that because they're equal to each other, so we substituted it in. We took WX since it's equal, and we put it in place of RS there. We call it the substitution property. Okay? Colton and Peyton, what did you guys get for number 10? I think you're right. That is a definition of midpoint. Go crazy.
I already had that.
Definition of midpoint. We did already have that. Okay? Here's the thing with the definition of midpoint. You can go either direction. Okay? Here on 10, we're starting out that LP is equal to PN. And we end with that P is a midpoint. On number 6, you start the other way. You start with Y as the midpoint, so XY is equal to YZ. Definitions can go both ways, right, Colton? Yes. Okay. Is that what you were saying to Nolan, I guess? I figured.
He was counting him out on his fingers.
So it's the same thing on that, okay? It's just reversed. If we're okay with reversing it, definitions can go both directions, okay? Just like saying wet means that it's covered in water. So if it's covered in water, that means it's wet. It can go both directions, okay? Not getting into that. I have my own stance on that. We're not getting into it.
Wait, what do you think?
After class.
Say what you think.
Another time.
Just,
Okay?
oh my
It's
God,
going
you
to turn
said
into
that.
ours.
Say
We're not
what you
doing it.
think.
We're not doing it. Okay? If UV is equal to UV, and UV is equal to UV. Sam and Nolan, what do you guys have? I agree. Definition of congruence.
I do not agree.
Too bad.
Don't
Okay?
care.
Don't care. Okay?
Okay.
So,
Oh.
number 11 here. You went from them being congruent
It is
to
not
them
that
being equal. That's our definition of congruent. If they're congruent, their measures are equal. If the measures are equal, they're congruent. Okay? On number 12, CD plus DE is equal to CE. Now, we have CD by itself, and we have CE minus DE. What did we do there to get there? What did we do to go from this to this?
Subtract.
Subtracted DE. If we subtract DE, takes it away from here. Subtract DE, we just write it there because there's no DE to take away. So it's a subtraction property. Okay? Hi, so hungry. Mr. Thomas, nice to meet you.
Oh man, I hate when my mom used to say that when I was a little kid.
Okay.
I'm so hungry.
Okay.
Like, oh.
Still hungry? Okay.
Or, what was it, come over Saturday and we'll have a Sunday. What is the one where?
Okay.
Okay.
Okay, come over Saturday, see the night, then we'll have Sunday. Okay, so if we go to the next page, we see this guide. We see this guide here, okay? What this is it says at the top, use the reasons below to complete proofs 1 through 6. So these reasons would be used for proof 1. These are used for proof 2,
I'm not flipped
3,
over yet.
4, 5, 6, okay?
She's rude.
You're a bot.
Let me handle those things, okay? Let me handle those things as a teacher, not you guys as students, please and thank you, okay? So these are guides to help us. These are a reason bank to help us. We're going to start off with reason banks, and then we're going to wean our way off of reason banks. We're going to work our way off of them, okay? And so, what I did here is if we flip our page, okay? Okay.
Hungry.
So for proof 1, I went ahead and included this on my slide here. I included this on my slide here so we could have it for an easy reference. Okay? I included that on my slide so we could have it for an easy reference.
That's not my
Okay? I know it didn't print out. It's not on mine either. But I included it on my slide.
Why do you put it on?
Sorry, maybe I'll change that in the future.
Yeah.
I should consider that. Okay. So, okay, thank you. Okay. So, we're gonna have our 2-column proof just like we had with algebra. Okay, we have our statements on the left, we have our reasons on the right. Now what's changed is we're not doing equations necessarily, we're not solving an algebra equation, we're doing geometry with it. So here we're given this picture, y is having a DF with point E somewhere in the middle, and we're told that E is the midpoint of segment DF. That's what we're given. And now we're trying to prove that if you double the measure of DE, you get all of DF. If you were to double DE, you get DF. That's what we're trying to prove, okay? If we double what's half of this, we'll get the whole thing. That's what we're trying to prove here, okay? And we're going to use these 6 reasons to get there. We use each one once here, okay? So reason 1, E is the midpoint of DF. What's our reasoning there? Given. Our first reason, literally every single time is given. You will never not have the first one be given.
I thought we were gonna go into like shapes and stuff.
Later, we were building up to it.
I don't get this part.
Sorry. Okay. I know given's the hard part. Okay.
No,
I know it's a
This
joke.
is the
Okay.
hardest.
So we're saying, boys. Thank you. Okay. We're saying if E is the midpoint of segment DF, now we know that DE is equal to EF. We know that DE is equal to EF. Okay, Marissa.
this is transitive.
Not quite. Okay.
Translucent.
Okay. We went from. Here's the hint, guys. What does it say in step 1? It says midpoint. Okay. So what?
Definition of midpoint.
So it might be definition of midpoint. Let me talk about this. Okay. Okay. So if we're told that E is the midpoint, does that mean that DE is equal to EF? That means it's in 2 different parts that are equal. That's what the definition means. Here's another hint I want you to think about long term, okay? Whenever you see a bunch of words, this is a bunch of words, and we got to an equation. Anytime you go from a bunch of words to an equation, it's probably a definition, guys. Anytime you go from a bunch of words to an equation, you probably use a definition to get there, okay? That's kind of a hint long term, okay? Thank you. Okay. So now we went from DE equals EF, and what changed to get us to step 3? Addition. What did we add to both sides, Gracie?
DE.
Yeah, we took this equation, we added another DE, and we took EF and we added a DE. So what property is that? The
Addition.
addition property. Okay. So on number 4, what happened here in the equation between step 3 and 4? The right side's the same. What happened to the left side?
Segment addition cost.
No, not quite. Okay.
Where?
What did we do with DE and DE? We
Added.
added them. We combined them, which is the same thing as
Simplify.
So I'm okay with us calling it CLT for combined like terms, or if you want to call it simplified, either one is fine by me. Yes. Okay? So we combine that DE and DE on one side, but DE plus EF is still the same here. So now this one's a bit of a change in gear. If we look from this equation to this equation, less 2 less raise down half plus get, okay? We don't see necessarily a direct correlation. We see DE and DF is still the same, but now we see this DF here, which we didn't have earlier. But if we look back up at our picture, DE plus EF now equals a whole thing DF. What tells us we can add this part plus this part to get the whole? We already used that. What? Segment addition? Does that mean we add 2 parts to get the whole? That's what we're doing.
That's what I meant. I meant like the
No, we don't
two.
need that comment.
Yeah, it hurt my feelings.
Okay, move.
The next one is.
We don't need that either. Okay. So now, what does that leave as our only option left, guys? Transitive. But before we just fill it in blankly without thinking, because that won't help us long term, okay? Let's think about why it's transitive, okay? So we went from, let me do this with pictures here, okay? We went, or with drawings, okay? We went from, here, okay? We have DE is equal to EF, DE is equal to EF, or DE plus EF, and DE plus EF. Here, we have it equal to 2 times DE. And that's what we see again here. Here we see it equal to DF, and here, DF. So we have 2 times DE and DF, they're both equal to the same thing. Because these two are both equal to the same thing, they're equal to each other. And that's what our transitive property says. If they're both equal to the same thing, they're equal to each other. Okay, hopefully that color code kind of helps us there. And so that is what our transitive property says. And so we were able to walk through this process, and we were able to get to the point to where we started with this, and we end up getting down to what we're proving there. Okay? Questions on that?
Will we always have like a word thing?
Okay? No. Okay? Like I said earlier, we're going to kind of wean our way off of that. Okay? Okay? Let's go ahead and write below this, please. Okay? So here, number 2, we're given a bank for this one as well, though. This one's a 4-stepper instead of a 6-stepper.
Given.
Okay? First reason is going to be what? That should be a freebie every time. I never want to see anybody get reason 1 wrong. Like,
That
seriously,
one was
please.
so
Okay?
hard though.
It's going to make me upset if anyone gets reason 1 wrong. It really will, okay? It's the easiest thing on our test besides writing your name. Reason 1 is always given. Okay? Okay? So,
Wait, are you
that's a
serious?
big rip.
Did you really?
Um,
How do you spell it?
I've forgotten E.
Okay.
How
Anyway,
do you do that?
guys, focus back up here, okay?
But
So-
we're talking about heels.
I know, we're going to stop talking about that. Okay? So, KL, segment KL is screwed to segment LN. Segment KL is screwed to segment LN. I like to label that on our pictures, so that's our tick mark, okay? We're told that they're congruent, so let's mark them congruent. So please mark that on your picture. Okay, I like to mark the information we know on our picture. I think that helps us a lot long term. Okay? LM, segment LM is screwed to segment LN. Well, we already have LN has 1 tick mark. So if LN, that segment is screwed to segment LM, that's also going to be 1 tick mark. So we marked our information. So what do we see from this anyway? That LN is congruent to what?
Okay.
Segment LK or KL. So we're probably going to use that at some point in our proof. That's
Okay,
something
does
to
that
keep in
mean
mind.
that LM and KL are congruent?
Yes, that's what we just talked about. Yep.
Okay.
Okay.
How come when you say L it starts with E? L.
That happens a lot with a lot of different letters.
I don't understand. I'm sorry.
Okay, when you say S, it starts with an E as well.
Oh my God.
Get your minds blown. Okay, anyway. So, how do we go from step 1 to step 2, saying that these things are congruent, now they're equal? They were congruent, now they're equal. What tells us we can change from congruence to equal signs? Of these 3 options, Which one tells us we can go from congruent to equal signs?
Transitive.
Which one would make the most sense given the words in it? Do any of those either have equal or congruent in them?
One of them does.
One of them does. Which
Definition
one?
of congruence.
It was probably definition of congruence. That's what tells us that if things are congruent, their measures are equal. If things have equal measure, they're congruent. Anytime you go from congruent to equal or equal to congruent, it's 100% of the time definition of congruence. Anytime you make that jump, it's going to be their definition of congruence. Okay. Okay. We're cutting out for combos. Okay. So on number two, now we have KL is equal to LM. What did we do from 2 to 3?
LN is no longer with us.
Okay. Let's look at this. Okay. KL, KL. LN, LN.
Oh,
LM, LM. Do we see that these two things, the red and the purple, KL and LM, are they both equal to the same thing in the light blue? So they're equal to each other. These things are both equal to the same thing, so they're equal to each other. What property tells us that? Transitive property. Now, ooh, big brain, okay? So, now we have that KL is equal to LM. This part up here, KL, is equal to LM over here. If those are equal, then we're saying that L is the midpoint of segment KM. How do we go from math equation into words? Or vice versa. We said we're going from words to math equation, we use a definition. So how are we going to go back from math equation to words? A definition. In this case, definition of midpoint, because it even says midpoint in the words. If KL is the same as LM, they're measured equal, that means L has to be the midpoint. No other choice. Okay. This is Haswell. Can you lead through proof 3 the best you can?
sure.
I have it here right here for the answer key as well. Yes, okay?
What's this right here? PQ. Why do we
Given.
have that?
This is the first one.
Because it's given. And then we're gonna go from PQ equals TQ to UQ equals QS. So we need to mark that. And then these two are, right? Yeah?
Yes.
Okay. So how do we get from this step to this step?
Well, there's no
They're
more congruence.
congruent here, they're equal here.
Hey. You look at me like that.
I can look at you however I want.
Oh. I'm looking at you however I want, man.
So we're going from congruent to
That's
equal.
what get you going. Wow.
What does that usually mean?
Congruence. Oh, there's two definitions.
Oh, I did mark wrong. Do you want to stop?
Also, no.
Because I'm like beyond done.
Yeah.
I don't need your help in
I
stop.
was talking to Colton about the
You will
cars.
just pay attention, it's not that hard.
Thank you, Ms. Haswell.
Thank you very much, Ms. Haswell, okay? We start off with given, then we go from congruence to equal signs using our definition of congruence. Wow, your handwriting is way better than mine, okay? Then quiz, okay? Then when we label it, I love that, okay? So then we have PQ plus QS is equal to PS. If we look at our picture, PQ plus QS is equal to PS. What tells us that two parts add up to the whole?
Midpoint.
Segment.
Segment addition postulate,
Oh.
okay? And if we look at the second one here, TQ plus QU, TQ plus QU, two parts add up to the whole, okay? So that is segment addition postulate. we don't happen to know that it's midpoint, because we don't know if anything's in the middle. We don't know anything's in the middle. So we can't say that it's this definition of midpoint. Okay? And then we use definition of congruence as well. Okay? Number 4, okay, TQ plus QS is equal to PS. Well, if we look at our picture, we don't really see anything with that. TQ, QS, getting PS. It's kind of confusing because plus must range on after we forget. But we might notice that TQ is what compared to PQ? Congruent, okay? If we look at an earlier equation here, TQ, QS, PS, do we see something similar right above it in step 3? QS, PS, plus, what's changed though?
The P.
The PQ is now a TQ. Were we told that the PQ is equal to TQ earlier? So what property tells us that we can switch those out if they're equal? Substitution. Okay, so we're going to say that's our substitution property. Okay, and what I want us to do, I actually switched to doing it just this year because I think it's really helpful actually. Like, I had never seen it before. I'm like, oh, why haven't I done this? I wish I would have done this in high school as a student. I wish I would have done this before as a teacher. Okay, we're going to put in parentheses afterwards what we substituted. Let's do must write down after let's forget because it helps us keep it so much more straightforward. Oh my goodness, it does. So we substituted PQ for TQ or TQ for PQ, whatever you want to word it. So we use the substitution property. Now we might notice we still have another substitution definition congruence intransitive left, okay? So keep that in mind of what we have left on this one, okay? That's going to help us this time. In the future, we're going to get more in a habit as we continue to practice. This just takes a lot of practice to get used to, okay? This is a whole different language, okay? So now in step 5, TQ plus QS is equal to TU. TQ, QS getting TU. What do we notice about SQ and QU or UQ? They're congruent. So could we trade out the SQ for UQ? Okay. Let's think about what happens here, okay? TQ, QS, TU. That's really similar to this equation, the second equation, step 3. TQ plus, and then equals TU equals TU. The only thing that changes is QU is now QS. Were we told earlier that QU is the same as QS? We're told UQ, but is UQ the same as QU? So this would also be our substitution property. Somebody said we could substitute it. I agree.
Okay, what's the difference between substitution and
Transitive. They're very similar. They're very similar. Let me see if I can clarify the difference on our next
That's
step a
how I
little
thought
bit.
it was.
Yeah, let me see if I can clarify the difference on our next step. Because there's a lot of times where I'll be honest, those two are very interchangeable most times. There's just a few times where they're not. Okay, so let me see if I can clarify that a little bit for you in a minute, okay? So substitution property here, okay? So we substituted UQ for QS. We took this QU or UQ, whatever you want to call it, word letters are interchangeable, they're flip them around for a segment. And we switched it with this QS. So let's go ahead and put that there. And we switched those two around, okay? And now we took away our substitution property. We only have transitive and definition of congruence yet left, okay? Well, when should we use definition of congruence? We're going from what kind of sign to what kind of sign? Equal to congruent, or the other way, congruent to equal, okay? We're going one way or the other, we should use definition of congruence. Is that what's happening from 5 to 6? No, so it's probably not definition of congruence, okay? But if we look here, and I'm going to try and draw it out here, okay? 4, we have TQ plus QS. Here we have, on 5, TQ plus QS. We have the same thing on both those, okay?
I don't understand how you got the PS.
Here?
No,
Here.
6,
Okay.
yes.
Well, that's what I'm talking about right now.
Okay.
Okay. So here we see PS, and we see it again there, okay? Then if I do orange again, we see those TUs again. So what we're saying is PS and TU, which we're trying to prove are congruent. We're trying to prove these are congruent big picture. So we're going to need to get to them. They're both equal to the same thing, aren't they? These are both equal to the same thing in the red.
Yeah.
So that means they're equal to each other. Okay, bless them, right now. Okay. So if they're both equal to each other, then we write that. So the transitive property is used to say, okay, when we have big stuff like this, when we have like a plus or minus sign, that's when we're going to use our transitive property. When we have our plus or minus sign in between stuff, that's when we're going to be more inclined to use our transitive property. Okay. Whereas substitution, was you just took a small part of this. Let me see if I can find a different color here that'll work, okay? Substitution was we took a small part of this, PQ and TQ, and we just traded out this PQ and TQ, and we just traded those two out. So you didn't change the whole side of the equal sign, you just changed a part of it. So if this whole part had changed, like this, changed to this, then we'd be transitive. But because only one part of it changes, you just change that little part. So you just plug one thing in versus changing everything. Does that make a little more sense, Grace? Okay, that's a great question to have, though. Okay, so this would be our transitive property, like we said a few times there. And now, we said definition of congruence is when we go to equal to congruent, or congruent to equal. Is that what's happening here? Yeah, it's the same exact thing. PS, PS, TU, TU. So that is literally just our definition of congruence. Okay? Now what I'm going to do, class, okay? Sorry for that distraction where I had to go off on Mr. Titus, okay? But what we're going to do is, I'm going to leave those 4, 5, and 6, okay? Those are examples that you could do. Let's see what's turns out. Okay? Those are examples that you could do on your own if you wanted to, okay, or if you need extra help, okay, because those have word banks there. On our homework today, we don't have word banks, okay, we don't have word banks on our homework, okay, but we're going to be using all the same kind of things we used in our notes, okay, so you can go back to your notes and look for those for help. You can look at that segment reference, the page we started on today, and use that as a big help to you, okay. You can use these 3 proofs we did together, use that as a big help to you, okay? I know we don't have much time, okay? What I want you to do for these last few minutes here, okay, please think for these last few minutes, I really want you to partner up with somebody right next to you, okay? Partner up with somebody right next to you, and I want you to try and work through number 4, okay? I want you to try to partner up with somebody next to you, and I want you to start on number 4. I don't expect you to finish. I really don't. I don't expect you to finish. I really don't, okay? But I want you to partner up with somebody next to you and work on number 4 here, okay? Just to start, okay? And as you have questions, please ask Mrs. Haswell or myself, okay?
I have someone next to me. His name is Demetrius. Whoops. He's the non-existent student.
That way, if somebody needs help.
Sure.